Alright, this is unbalanced forces with kinematics. So really what we've got is any situation where your forces are going to be unbalanced. As a result, you're going to get an acceleration, and then we're just going to use that acceleration with our kinematics formula. So you can use this on flat surfaces, tables where the pulleys on both sides, cliff with a pulley, any kind of situation. I'm going to do it with inclined plane because that's the kind of situation that you get like let's say 85% of the time. You're going to get an inclined plane. Let's call it the hill or a hill. The hill's going to have a 14-degree angle. We're going to say that the hill's got a coefficient of friction of 0.23. And let's see here. What we'll do is let's take our skier. And now what's happened is our skier has fallen. Let's maybe, since this is a certain chemistry teacher that we know, they're going to have mittens that are going to be attached to strings, and their toque will be flying through the air. Wow, there we go. And of course they're spinning around wildly, uncontrollably. So there is, oh, and I guess we need a couple of skis flying through the air. There we go. That is the information. We also know that our chemistry teacher has a massive 85 kilograms. That's about the only nice thing I'll say about our chemistry teacher, is that they have a massive 85. Alright, we're going to be asked to find the acceleration. Okay, that's our first thing. Then I'm going to try to get you to find final velocity after 10 seconds, as well as your distance traveled down the hill or displacement down the hill after 10 seconds. Those are the three things that we're going to find. So let's draw out our information that we have. We have the fact that Fg is coming down. We know that Fy goes this way. We know that Fx goes that way. We know that our normal force points upward. We know that our Fx comes out pulling you down the hill, and you know that your force of friction is trying to oppose all of this. So we have all that. We also know that you're going to end up traveling this way. So let's call that direction our positive direction. But for all our answers, we'll just say down the hill. Okay? So let's start off first. We're going to find the acceleration. That's going to be our very first step. Finding the acceleration. This is what we've been doing for the entire unit. We're going to do a sum of forces, and we're just going to look at the forces we have. I'm not even going to bother turning this thing into a linear situation. I think I can do it just by looking at it. So I'm going to say that my Fx is going to add to my negative Ff, and that's going to be equal to mass times acceleration. My Fx is going to be Fg. Remember, it's an inclined plane. That's 14 degrees. So that's going to be Fg sine of 14 minus mu Fn equals 85, and the acceleration is what we're looking for. So let's fill all this in. 850 sine 14 minus my mu value, which is 0.23. My normal value is going to be 850 cosine 14. And 85 times A. Okay, that is the information we have. Solve this all out. 850 sine 14 is 205.6. 0.23 times 850 cos of 14 rounds to about 190 equals 85A. 205 subtract 190, that's 15.6 equals 85A. And your acceleration, once you figure that out, 15.6 divided by 85, you're going to get an acceleration of, it's really small, 0.18 meters per second squared. That is going down the hill. Okay, you can call it down the hill, but we've also said that down the hill is positive, so if you'd like, you can call that thing positive. It's up to you. That answers part one. Second, you're trying to find the final velocity after 10 seconds. So rolling down the hill, you know the acceleration is really not that big. It's actually quite small, so you're not really going to have that big of a final velocity after 10 seconds. I'm going to use the easiest formula there is, Vf equals Vi plus At. Final velocity is what I'm looking for. In this situation, unless you're told otherwise on these kind of things, you're always going to assume that your initial velocity is 0. So initial velocity is 0, plus my acceleration, which was 0.18, and the time frame, 10 seconds. Your final velocity then ends up equaling 0.18 times 10. That's 1.8 meters per second, and that's down the hill. I've also seen people, instead of calling it down the hill, they can say down the slope, and they put down the slope, and then up the slope is UTS, whatever. Or you could call it positive because of the fact that we were going down, or we called positive down. I guess 1.8 meters per second doesn't really tell me anything, so why don't I go over here, 1.8, I times it by 3.6, and that tells me that that's 6.5 kilometers an hour. Just, not that it asks it in the question, but at least now I can put that into a velocity that I understand. So 6.5 kilometers an hour is not that fast. Third, we want to find our D traveled after 10 seconds. So they start here. How far are they after your 10 seconds of flipping down the hill? You can use D equals 1/2 VI plus VFT. You can use D equals VIT plus 1/2 AT squared. And you can use VF squared equals VI squared plus 2AD. 3 choices. Distance, distance, distance. I am not going to use this one because I found my VF. I don't want to use it in my equation. I'm not going to use this one because I found VF, so I don't want to use it in my equation because I might have got this wrong. So I'm going to use this one here. D equals VIT plus 1/2 AT squared. D equals, my initial velocity is 0, travels for 10 seconds. My gravity is 0.18. And time is 10 squared. That ends up equaling 9 meters down the slope. There you go. 1, 2, 3 things that you can be asked about unbalanced forces. You can ask a whole bunch of things. You can give the length of the slope and figure out, using all your equations here. That's all it is you find acceleration first, and then you just use your kinematics equations to answer whatever question that you might be asked. Okay, that was your unbalanced forces with kinematics. Enjoy.